Welcome to Derectronic, where we experiment, learn, and build with electronics. Let us now have part 3 of our video series on operational amplifiers. However, this time around, we will be connecting our operational amplifier, our 741 integrated circuit, to a DC supply source. The schematic diagram of that circuit is shown here. Now, we still have our 741 IC here, and the pin-out configuration of the IC as a review, I'm showing it here on the right side. Similar with our inverting and non-inverting op-amp circuits using AC power supplies, we will still be using in this circuit 5 pins of that IC. Pins number 2, 3, 4, 7, and 6 respectively. Pin number 6, which is the output of the IC, will be connected to a feedback resistor, 10 kilo ohm in this case, and that 10 kilo ohm feedback resistor will be connected in series with the 10 kilo ohm input resistor. And that resistor, the input resistor, will be connected to ground. Pin number 2, which is the inverting input of our OpAmp 741 IC, will be connected to the junction between the feedback resistor and the input resistor. This setup is similar to the non-inverting OpAmp we did in the last video. However, unlike that circuit in the last video we did, this circuit will not have a coupling capacitor. Why? Because this time around, we're using a DC supply source, not an AC one. So the coupling capacitor is not needed because there are actually no AC signal to let pass through or even DC signal to block. It's all DC here. Now, as you can see in this diagram, the positive terminal of our power supply will be connected directly to the non-inverting input, which is pin number 3, which makes this circuit a non-inverting operational amplifier circuit. Here, pins number 4 and 7 of the IC will still be connected to negative 15 volts and positive 15 volts, respectively. Now, given that this circuit is still an operational amplifier circuit, okay, we should expect that the voltage here on the input, okay, will be amplified to the output, which means at the output here, which we will be connecting a multimeter here on the output to measure the DC output voltage here. So we should expect that the DC output voltage measured here through the multimeter to be an amplified version of the input voltage. Okay. Now, the gain or the amplification factor will be dependent on the values of the feedback resistors and the input resistor. Given that this is a non-inverting op-amp, the formula for the gain would be the same as in the last video, which is gain is equal to 1 plus the ratio of the feedback resistor over the input resistor. So in summary, we could say that for an inverting or non-inverting operational amplifier, it doesn't matter what would be our supply source. We could have an AC supply source or the DC supply source. The gain or the amplification factor will be computed the same way, regardless of the supply source, AC or DC. Now, actually, the gain for this particular circuit is easy to compute. Why? The feedback resistor value and the input resistor value is the same, which means if I have 10 kilo ohms over 10 kilo ohms on the ratio here, that will be equal to 1. Plus 1 will give me 2. So the gain for this circuit is 2, which means what we should expect on the output here, okay, the DC voltage on the output. The DC voltage on the output should be more or less twice of the input. So if you make, let's say, several tests, let's say we first test 0.5. Then after that, we increase the voltage here on the input, let's say to 1 volt. Then we increase again to 1.5 volts and so on. Okay. For each pass or for each test, the voltage on the output should be twice of that in the input. Here is our COM3 Lab Protoboard where we will again construct our non-inverting op-amp circuit. As you can see right here, I've already placed the 741 IC. Unlike in the previous 2 videos where I put the IC here at the top, now I'm putting the IC here at the bottom, just to illustrate that you could actually put the 741 anywhere on this board. Now, the notch of that 741, let me just explain that here, closer view. The notch or the half moon notch is here again. I place it here. It's our left-hand side. It's facing here to the left-hand side. So if that's the case, again, just have a review. Pin number 1 is here at the bottom. Then pin number 2, 3, 4. Then at the other side, you start there at the right-hand side. Okay, pin number 5 here, 6, 7, 8. Now, let's build the circuit from here now. So let's start off with the input resistor and the feedback resistor, which I have here. Again, I would like to remind you guys that if you're given two resistors that are different value, make sure you correctly identify which is the feedback resistor and which is the input resistor, because you can't have the connections interchange. In this demo, I have the same value for both input and feedback resistor. So it doesn't matter whether I use the 10 kilo ohm on the feedback or the 10 kilo ohm on the input resistor, because it's the same value. However, if you're given different resistor values, make sure to correctly identify which is the feedback resistor and which is the input resistor. Let me connect these two resistors now. Okay, I'm going to use this one of the 10 kilo ohm resistor as my feedback resistor. It should be connected on pin number 6. Let me connect it this way, a little bit different from what we did before. Like this. Okay, there. Okay. Then, I have another resistor here, also 10 kilo ohm, which is my input resistor. I'm going to connect it in series with this resistor here, the 10 kilo ohm resistor or feedback resistor. Okay, in series, one leg will be in series with the 10 kilo ohm resistor, the feedback resistor, and the other leg, I will connect it to ground. I'm going to use one of these power rail. I'm going to use the blue one, the bottom blue power rail for this purpose. Okay, so connected in series, and the other leg is on the blue power rail, like so. There. See the connection here. Okay, so it's in series with the feedback resistor, this one input resistor, and the other leg is connected to ground. Now, since I've established that the blue power rail, the bottom blue power rail is our ground, I'm going to connect now the power source ground to that power rail. Now, for this video or for this circuit, we're using a DC supply source, variable. So I'm going to use this too, okay? So this is my ground here, and this is my positive terminal will come here. So the ground terminal of my DC power source, my main DC power source, okay, will be coming from here. Let me connect now a wire from there. So black wire first. Here, negative. I'll connect now to the blue power rail here, the bottom. That's my ground. It's my ground now. Negative. Okay, ground terminal, blue power rail. Okay, now. Okay, if you could also remember from the circuit, schematic of our circuit, pin number 2, which is this pin, is to be connected to the junction between the feedback resistor and the input resistor. So I'm going to connect pin number 2 using a jumper wire, like this one, to this junction here, between the feedback and the input resistor. Let me do that now. Pin 2, connected here between the two resistors. There. Pin number 2. Connected there. You see there. Okay. Now, the positive terminal of our variable DC supply will connect directly to pin number 3 here on this circuit. Now, let me do that now. I'm going to have one wire. I'm going to use a red wire this time around. Connect to U plus or plus U here, the positive of our power supply, variable power supply. And I'm going to connect it directly to pin number 3 here. Pin number 3. There. Pin number 3, U plus. Now, what is missing now is the positive 15 and the negative 15 supply source for our 741 IC, because the 741 IC will not switch on if I don't connect its power pins. So one of the power pins is we're going to use the positive 15 volts here at the top. I'll connect this one to pin number 7, just like in the previous videos. Positive 15 to pin 7 first. Okay, there. Okay, pin 7. And negative 15. The negative 15 volts power source will be connected to pin number 4. Make it to pin number 4 here. down. There. It's pin number 4. There. Negative 15. The ground for the fixed power supply will have to be connected on the same ground where our main power supply, the variable power supply is connected here at the blue rail, bottom blue rail. So here, ground, I'll connect to the bottom blue rail here also. There. Same connection. So the two grounds are connected on the same blue power rail. See there. Okay. Now, to measure our output, since we have a DC supply now, we're not going to use the oscilloscope this time around. What I'm going to use is one of the multimeters. I'm going to use multimeter number 2 for this purpose. I'm going to use multimeter number 2. Since I'm measuring voltage, I'm going to connect here. My red wire, my positive terminal will come here from V, and my negative terminal will come here from COM. So let me just do that. So here's the terminals. I'm going to connect my red wire, a red wire on V here. Let me use a shorter one. Okay, here. And a black wire, power wire on COM. So where do I connect that? Okay, since the multimeter will measure output, the output pin of our 741 IC is pin number 6. So I'm going to connect this one now. The positive terminal of the multimeter on pin number 6. Let's do that now. Pin number 6. There. Pin number 6. Okay. And the negative of our multimeter, the COM, this one, will have to be connected to ground, to the ground terminal. So let me just move this all the way around. And I'm going to connect it on the blue power rail down. I put it here all the way on the end. No problem here. There. So once that is done, our connection is more or less complete. So what I just need to do is switch on the board. Switch on the board, our Protoboard from here. Switch this. Then I have to switch both of these DC supplies because I have some wires connecting here. I have to switch the one at the top here on and the one here at the bottom also switch on. Okay, and I'm going to take a look at the results using the COM3 Lab companion software. For the COM3 Lab companion software, we must first set the function generator to output a DC supply voltage this time around. So I'll open the function generator from here. So what I will select here is DC, straight line here, DC. And initially, as per our circuit, okay, I'll initially set this one to 1 volt or 0.5, okay, 0.5 volts, 0.5 volts. There. So 0.5 volts DC. Now, we don't have any oscilloscope connected to our circuit. However, we have a multimeter connected to it. So what I'll do, I'll open up the multimeter and we connect it to multimeter number 2 here. Set your multimeter number 2. I'll put it here at the middle, including the right there, DC multimeter here. Okay, I'll set the multimeter to mesh to DC voltage. Actually, it's DC voltage already. Let me just beat it back. There, it's DC voltage already. So what will happen here? Okay, we'll first check the value of the function of the DC supply source and see the reading on the multimeter here, which is on the output. So the one here on the left, the one on the function generator is our input voltage. The one here on the multimeter is our output voltage. Based on our discussion earlier, the amplification factor should be more or less be equal to 2 based on the values of the feedback and input resistors for our circuit. Let's see if we have that one confirmed. Okay. Let me just put this on so that we can see it better. There. Okay. Now actually the board is on already. Okay. Our supply source is set to 0.5 volts. Check the output. 1.003. More or less twice the value of our input. The output is twice. So it's amplified. The input was amplified 2 times on the output. Now let's just change the input now from 0.5. Let me set it to 1 this time around. 1. Let's see the output. What happens on the output? Okay, see here. I changed the input voltage to input DC voltage to 1 volt. Check the output now on the multimeter. It's 2 volts. Again, 2 times. Okay? The input was amplified twice on the output. Times 2 of the input. Let's change the input again. From 1, let's say to 1.5. Enter. Check the output voltage. It's now 3. So 1.5 times 2 will be more or less 3. It says it's 3.01. Very close. Okay? More or less, the amplification factor is 2 still. Okay? Let's change it. Let's have another value for the input. Let's say 2 volts. So we're expecting, see, same. Twice the value. The output voltage is twice the value of that of the input. 2 volts on the input, we have 4 volts on the output. So let's have one more test. Let's say 2.5. There. See. So at 2.5 volts on input, the output is 5 volts. As you can see from this test, as mentioned in the theoretical discussion, it will not matter what type of AC or what type of power source you have for our amplifier circuits, operational amplifier circuits, whether that be inverting or non-inverting. So whether you have a DC source or an AC source, the amplification factor is determined the same way. It's dependent on the value of the feedback resistor and the input resistor, and the same formula will be used regardless of the power source, as you can see here. Now, with that, I would like to conclude the video for today. And as always, I'm encouraging everybody to keep experimenting, keep learning, and I hope to see you all next time here in Derricktronic.